Hello everyone, my name is K. Rajesh. I am from CSC B section. Today's my topic is about hierarchical feature selection for random projection. Introduction. Random projection algorithms have been utilized in many applications such as face recognition and are confirmed to be efficient concerning with the training procedure. Neural networks are very popular in solving computer vision problems, such as intelligent vehicles, text detection, mo- motion estimation, and image understanding. One of the typical random projections implemented by the single-layer neural networks with randomly generated neurons is extremely learning machine (ELM), which can be efficiently trained with the closed-form solutions. A simple yet efficient criterion is proposed to select useful features for neural networks. The criterion used for ranking the usefulness of features, which is based on the value of output weights, is easy to calculate and effective to estimate redundant and noisy features. Our method establishes a new way for a network architecture design and is of inspiring contribution to this field. Extensive experiments are performed on the variety of data sets, including both classification and recognition tasks, and confirm the effectiveness and efficiency of the proposed method. A hierarchical selection scheme is proposed to choose useful features in a very efficient manner to accelerate the selection of features on large-scale datasets. Useful features are selected hierarchically, which avoids the selection from the whole feature pool. Therefore, the large matrix reversion is avoided, which largely accelerates the selection procedure. However, more features are required when it is applied to rather large data sets, since the features are randomly generated. Hierarchical feature selection. In order to elevate redundant features and avoid large matrix reversion, a very simple yet efficient feature selection method is proposed to hierarchically choose significant features from a large amount of randomly generated features. Particularly, the first step of the proposed method is to generate features randomly. Then the features are split into several groups. For each group, the original algorithm is performed to learn the output weights, which can be utilized to evaluate the importance of the features. Specifically, larger weights indicates the feature in more importance, thus the features can be ranked based on their weights. After the ranking and selection, features from different groups are aggregated together. The selection procedure is performed several times hierarchically, and a very compact yet effective network can be generated from the numerous features in a very efficient manner. Since the input weights of hidden neurons is randomly assigned, it can be seen as a random projection in which many redundant features might be yielded during the training process when a good performance is achieved. To, to relieve this problem, a simple criterion for feature selection is proposed to rank and choose features based on the output weights, which can be utilized to evaluate the importance of the features. The output weights are sorted in descending order after the importance of the features is ranked. A subset of features can be selected. Proved by experiments, this method is very effective to prune redundant and noisy features. and generate better performance than the original algorithms. These are some parameters which will affect the performance and efficiency of proposed methods. They are not easy sensitive to different data sets. In all experiments, some parameters can be used for different classifications and recognition tasks over different data sets. The parameters are summarized as follows, and its selection is investigated in experiments. The first parameter that we should determine is the ratio of remained features in the selection procedure. Large ratio tends to yield better performance, but the training speed is limited. While small ratio can be trained more efficiently, a proper ratio can assure good performance and fast training speed at the same time. The final size of selected feature is a factor that affects performance and the testing speed of the algorithm. A large number will yield better performance, while a small number will be faster in training and testing. Based on the ratio in feature selection procedure and the final remained number of features, the size of feature pool can be determined by the number of layers in a hierarchical selection scheme. The more the number of layers, the larger the feature pool. A large feature pool can produce better performance at most of the time. However, the training speed will increase a lot in hierarchical selection procedure with more layers is performed during training. To accelerate the selection of features by avoiding large matrix inversions, a hierarchical selection strategy is proposed. First of all, numerous features are randomly generated to serve as a feature pool. Then, features in the pool are split into several groups on which the feature selection procedure is performed. To obtain more compact network, the same feature selection can be conducted on the selected features, which forms the hierarchical scheme. To confirm the efficiency of the proposed method, extensive experiments are conducted. Though the experimental results we find that the efficiency of random projection can be largely improved with a comparable performance so that the proposed method can be used for rather large data sets. In this section, some experiments are first conducted to prove that the features with the large output weights has a higher probability to generate better performance. Then the performance and efficiency of the proposed method is evaluated on both classification and regression tasks. Conclusion: to prune redundant and noisy features, a hierarchical feature selection method is proposed. The selection method which can be used to select useful features from feature pool is based on the simple but effective criterion regarding to the value of the learned weights. Based on the selection criterion, a hierarchical selection scheme is proposed to accelerate the efficiency of the algorithm. Utilizing hierarchical feature selection in single layer, neural networks can generate very compact networks, which have comparable performance with several widely used algorithms in classification tasks, and better results than traditional methods in recursion tasks. and the testing speed has shown its priority in both classification and recursion tasks. Thank you.